Okay, so hello students, welcome to our channel. So today we'll solve more problems of quantum mechanics, and these are very much helpful in different kind of examination. So let's try to solve the numericals. So you can see the first question, that if L plus and L minus are the angular momentum ladder operators that we already know, then we have to find out the expectation value of L plus L minus L minus L plus, this thing, the expectation value of this, right? On a particular state, L is equals to M and M is equals to 1, right? The question is very simple. This is one quantity that is given to us, L plus L minus L minus L plus, and we need to find out the expectation value of this on this state LM. That means this thing we need to find out. So how to do this? Very simple. First we need to see this thing. What is this operator? This whole operator. So you remember this thing? If you write L plus L minus operator, that is always L square minus LZ plus H cut LZ. Remember this one? We always write down this. Similarly, what is L minus L plus? This is L square minus LZ square minus H cut LZ. So when you add these two things, so this is L plus L minus plus, sorry, this is L minus L plus, this is nothing but 2 times of L square minus LZ square. Very simple. ठीक है, तो आपको ये याद होना चाहिए एग्जाम में that what are these values, what is the value of L plus L minus and what is the value of L minus L plus operator. Fine, we can put in this. So this is nothing but Lm, and this is 2 times of L square minus LZ square, and this is again Lm. Now what is this thing? 2 I can take outside, and then what is Lm? 1 1. So this is 1 1 on L square, and again 1 1 I can put, then minus 2 times 1 1 on LZ square, again 1 1 state, right? And now what is this thing? If we operate L square on n state 1 1, this we already know. What is L square operator on any state Lm? This thing you know. What is this? L into L plus 1 H cut square Lm. Fine. And what is LZ square on state Lm? This is simply M square H cut square Lm. So I can use these two formulas here. So this will give you simply 2 L square on this state 1 1. This is 2 H cut square 1 1, right? मैं लिख भी सकता हूँ यहाँ पे 1 1 as it is. This is 2 H cut square 1 1, and this is minus 2, and what is this? One 1, and this is simply H cut square 1 1. So finally this 2 H cut square and this will give you simply 4 H cut square, and 1 1 with 1 1, because of the orthonormality condition this will becomes 1. So this is 4 H cut square minus 2 H cut square. So our answer is simply 2 H cut square. Fine. This is a very straightforward question. The only thing that you have to remember in this question, that these two values, and you have to know these two things straightforward. Fine. Okay, let's go to the next question. Yeah, this is also interesting question. So we have to find out the value of this commutator operator LX with R square. How to do this? So see how I will handle this question. So what is given to us? LX with R square. Can I write it like this? LX with X square plus Y square plus Z square. Further I can write it like this: Lx with x square plus LX with y square plus LX with z square. Fine. This is how I can write it like this. Now see, what is this LX with x square? This is always 0. This is always 0. कैसे करना है, आपको एक फॉर्मूला याद रखना है, that commutation of any Ri with Lj, this is always epsilon ijk iota h cut rk. Just remember this thing. How? For example, x with Lx, x with Lx, that means I is equals to j. When I is equals to j, this epsilon ijk is 0. This is the property of this thing, epsilon ijk. This is always 0 when I is equals to j, if any two terms are equal, and this is 1 when I is not equals to j, not equals to k. So this is 0. Similarly, if you want to find out x with Ly, so what is this? I can say iota h cut z, and so on. You can find out other terms also. So I will use the same thing here. So this term is 0. Now what is this term? How to write down this one? So just let me write down, this is equation 1. So let me handle the first one, this one. Lx with y square. Can I write it like this? Lx with y, y outside, minus y, Lx with y, right? Now what is this term? I can use the same formula, this formula here. Can I write it like this? I can take minus sign outside, and this is y with Lx with y. Again same here, minus sign I can take outside, so this will become plus y Lx. So what is y Lx? See this formula. Instead of r I can put y, instead of this I can put Lx. So this will give you y Lx. This will give you minus iota h cut z, minus iota h cut z. This is the opposite of this one, similar like this. So I can write it like this. This is minus iota h cut, so minus iota h cut y. I'm sorry, let me just clean it. Minus sign as it is, this is iota h cut z y plus this y as it is, and that is also minus iota h cut z. So this term is nothing but this is minus sign here and minus sign, so this is plus, this is iota h cut zy minus iota h cut yz. Fine. Now similarly you can find out this term also, Lx z square. I can write it like this, Lx with z, z is outside, right, minus z is outside, Lx with z. Now what is Lx with z? Or you can also write it like this, you can take minus sign common, and this is z with Lx, this z as it is, this will become plus sign, this z is as it is, z with Lx. So this will give you simply minus iota h cut z with Lx. This is zx and this is y, yz plus z iota h cut y. Fine. So you can cancel, you can see now you can put this term and this term in equation 1. So these are cancelled with each other. Fine, you can cancel them with each other. So your final answer will be 0. Okay. So this is how you can deal these kind of questions. Okay, see the next one. This one is very interesting question. So first see the question what they are asking, that a normalized ground state wave function for hydrogen atom is this. This is the ground state wave function given to us, where A is the Bohr radius, R is the distance of the electron from the nucleus, located at a region, the expectation value of 1 by R square. So what we need to find out, we have to find out the expectation value of 1 by R square on ground state. On ground state. How to do this? Ground state wave function is already given to us. Now, what is this ground state wave function? This is total wave function or radial part of the wave function. How to find out this? So for that you have to remember that what is the radial part of wave function. So for hydrogen atom, you remember the radial part of wave function is nothing but 2 over a naught to the power 3 by 2 e to the power minus r by a naught. A naught or a, you can put anything. Okay, this is the radial part of wave function. And what is the total wave function? R theta phi radial part and y l m theta phi angular part also, right? Then this will become 2 over a naught to the power 3 by 2 e to the power minus r by a naught into, for ground state this is always 1 over under root 4 pi. So this becomes 1 over pi a naught under root e to the power minus r by a naught. Now you see this is similar to this one. So I can say that this is the ground state wave function and this is total wave function is given to us. So if total wave function is given to us, how to find out the expectation value of any quantity? Expectation value of any quantity जैसे अभी हमने किया था. So for this one I can say 1 by r square of expectation value of this 0 to infinity limit of r, then 0 to pi limit of theta, 0 to 2 pi limit of pi, right? And then this quantity as it is 1 by r square mod psi square, square of this one. So this is 1 over pi a naught to the power 3. So this is actually 3. And this is e to the power minus 2r by a naught into r square dr d theta d phi. Remember this thing, there is always r square here. Then you can easily solve this integration. This r square you can cancel. So this comes out to be 1 over pi a naught cube. And then you see theta and phi, when you do the integration of theta and phi, then you always get 4 pi if you remember this thing. Or you can do the integration also. I am just directly writing. This is 1 simply 4 pi and this is 0 to infinity e to the power minus 2r by a naught dr. You can solve this integration. So when you solve this comes out to be a naught by 2. Fine. So just put all these things, this pi and pi you can cancel. This 2 and this 4 you can cancel. This and this a naught you can cancel. So this will become 2 by a naught square. Fine. So this is how you can do this kind of question. But remember, in examination we will not do this kind of question in this way. How to handle this question? So here I have written the expectation value of these quantities, some quantities, directly for any state. You see, this is the for the ground state, and for ground state wave function is very simple for hydrogen atom. But let's suppose they may ask about first excited state, second excited state, then how you will deal this thing? कैसे करेंगे? That becomes very complicated. Why? Because the wave function for first excited state, second, third, fourth, it becomes very complicated. So in that case, you cannot handle these integrations. These integrations are very complicated, right? And we have to consume the time also, because time is very important in examination. You have to complete your question in a certain period of time. So in that case, it is becomes very important thing that how to deal that question as soon as possible, right? So what we can do, we can use these tricks, that expectation value of 1 by r is 1 over n square a naught for any state. N represents the state. Similarly for r is square, 1 by r square. You can deal. Let's suppose for n is equals to 1. For this particular case, n is equals to 1 is the ground state, right? And what we need to find out? Expectation value of 1 by r square. So this formula I can directly use. कैसे करेंगे देखिए, 2 divided by n is equals to 1. And if n is equals to 1, what is the value of L? L is always 0. So you can put L is equals to 0 here. So this is 0 plus 1 a naught square. You see, this is simply 2 by a naught square. तो कितना टाइम आप बचा सकते हो डायरेक्टली करके, right? So I will suggest that for examination purpose, just directly remember these things, whatever I have written here. Expectation value of 1 by r square, expectation value of r and r square. Fine. Okay, then might be helpful for you. So let's do the next question. This is also interesting question. So first understand this question, that consider a system of 8 non-interacting identical quantum particle of spin 3 by 2. ठीक है, तो हमारे पास में 8 पार्टिकल हैं and these 8 particles have spin 3 by 2. ठीक है, in one dimensional box. The minimum excitation energy of the system is, क्या होगी excitation energy? So first see, spin is given to us 3 by 2. If spin is 3 by 2, then tell me what is degeneracy of any particular state. What is degeneracy? Degeneracy is always 2s plus 1 for any spin. Like suppose spin is half, then it is 1 by 2 and minus 1 by 2. So for 3 by 2, I can put this thing 2 into 3 by 2 plus 1. So this degeneracy is 4. What is the meaning of this degeneracy? It means, let's suppose you have a ground state, n is equals to 1. First excited state in 1D box, n is equals to 2. The next state, n is equals to 3. Now because of this speed degeneracy, each state is split into 4 different states. This is the meaning of this degeneracy. This state has 4 different states. Fine. Similarly, this also is split into 4 states. First, second, third, fourth. Same goes with this also. First, second, third and fourth. This is the meaning of degeneracy. Now these are the electrons. इलेक्ट्रॉन्स क्या हो सकते हैं? एक स्पिन स्टेट में सिर्फ एक इलेक्ट्रॉन हो सकता है. तो जब इलेक्ट्रॉन्स को हम इन स्टेट्स में फिल करेंगे तो क्या करेंगे, हर एक स्टेट में सिर्फ एक इलेक्ट्रॉन होगा. इलेक्ट्रॉन यहाँ होगा तो दूसरा यहाँ होगा. एक स्टेट में 2 इलेक्ट्रॉन नहीं हो सकते. थर्ड यहाँ, फोर्थ यहाँ, एंड सो ऑन. नाउ हाउ मेनी इलेक्ट्रॉन्स वी हैव, और you can also say that because they have not mentioned the electrons, you can say these are the fermions. Both are the same thing. We have 8 fermions here. तो ground state energy क्या होगी? We know the energy. n square pi square h cut square or 2m l square, or I can directly say this is n square E naught. This is term is E naught. Fine. Now for this particular state, what is the energy? I can say the energy is n is equals to 1 E naught. For this one, what is the energy? N is equals to 2 4 E naught state, and this is n is equals to 3 9 E naught state, right? Now you see in this state, first try to find out the ground state of the total system. तो ground state कब होगी, क्या क्या possibility होंगे? 8 particles हैं, 4 यहाँ आ गए, 4 यहाँ आ जाएंगे, 1 2 3 4. This is the best possibility. So what is the total ground state energy? अब देखिए यहाँ क्या होगा, हर एक स्टेट की एनर्जी ई नोट है, ठीक है? तो मैं क्या कह सकता हूँ, 4 पार्टिकल है, तो आई कैन से दैट 4 मल्टीप्लाई बाई ई नोट. दिस इज 4 ई नोट. सिमिलरली दिस आई कैन से 4 मल्टीप्लाई बाई 4 ई नोट. सो व्हाट इज द ग्राउंड स्टेट एनर्जी? EGS. So I can say this is 4 E naught plus 16 E naught, these two, right? So this is 20 E naught is the ground state energy. Now tell me one thing, what is the excited state? कब होगी excited state? So can I say कि यहां से कोई एक फर्मियोन निकल के यहां चला जाए? That is the first excited state, because यही possibility है. Now what is the energy in this particular situation? Energy in the excited state. Ground state पे देखिए कोई फर्क पड़ा नहीं पड़ा, sorry, for n is equals to 1, that is as it is 4 E naught plus. यहां देखिए क्या हो गया, एक पार्टिकल चला गया यहां से. Now we have only 3 particles, so can I say this is 3 into 4 E naught? So this is simply 12 E naught. And what about this? Here we have one particle, so this is 9 E naught multiplied by 1. So this is 9 E naught. This is 9 E naught. So what is total energy? This is 25 E naught. This is the ground state energy. This is first excited state energy. Now they are asking about the minimum excited energy. So this is the difference of these two. Minimum excitation energy is nothing but 25 E naught minus 20 E naught. This is 5 E naught. E naught is already given, so I can fill in these blocks that this is 5. Right? So you see the calculation wise very simple. आपको ज़्यादा कुछ calculation नहीं करना है. But the concept is very important in this question. कि spin 3/2 का क्या मतलब है, 4 states में कैसे divide होगा. Then what is the meaning? So this we already know that what is the meaning of spin 3/2. Then how we are filling these states, how we are calculating the energy, that is also important thing. Fine. So I hope you understand this one. So let's see the next question. Let me just change the color. Yeah, this is again a conceptual question. There is no calculation in this question. You have to just understand the concept behind this question. First see the question. 2 electrons are confined in 1D box of length L. 1 electron state is given this. Okay, एक इलेक्ट्रॉन की स्टेट इस तरह से डिफाइन है. What would be the ground state wave function? This is the ground state wave function if both electrons are arranged to have in same spin state. जब दोनों इलेक्ट्रॉन सेम स्पिन स्टेट में होंगे तो सिस्टम की ग्राउंड स्टेट क्या होगी, ग्राउंड स्टेट का वेव फंक्शन क्या होगा, दैट वी हैव टू फाइंड आउट. कैसे करें? फर्स्ट यू सी वी आर टॉकिंग अबाउट इलेक्ट्रॉन्स. Electrons are the fermions. If they are fermions, then I can say their total wave function. Total wave function must be anti-symmetric. I hope you know this thing, because the wave function of fermions is always anti-symmetric. That's fine. Now see, the total wave function has two parts. One is the space part and second is the spin part. स्पेस पार्ट कौन सा है? ये वाला है जो अभी हमने लिखा है √2/L sin n pi x by L फॉर ए पर्टिकुलर सिंगल इलेक्ट्रॉन. स्पिन पार्ट को हमने लेट सपोज डिफाइन कर दिया साई स्पिन. ठीक है, दिस इज द स्पिन पार्ट. नाउ व्हाट इज गिवन टू अस that electrons are arranged in same spin state. That means both the electron has same spin state, singlet state में है, right? So अगर दोनों एक ही spin state में है तो spin part क्या हो गया उसका? Symmetric हो गया. आपको निकालने की जरूरत भी नहीं है कि क्या होगा. This is symmetric. अब ये symmetric है, टोटल हमें एंटी सिमेट्रिक चाहिए, तो क्या होना चाहिए ये वाला पार्ट? This must be anti-symmetric. Then only we can say that total wave function must be anti-symmetric. अब anti-symmetric कैसे होगा? क्योंकि यहां पे हमारे पास क्या है? दो इलेक्ट्रॉन्स हैं. So I can say that psi x1 x2 this must be combination of two spins. Let's suppose एक के लिए हमने psi1 से रिप्रेजेंट कर दिया, दूसरे को psi2 से रिप्रेजेंट कर दिया. psi1 psi2 माइनस psi2 psi1 एंड नॉर्मलाइजेशन के लिए हम क्या कर देंगे? 1/√2 लगा देंगे. दिस शुड बी द फॉर्म, बिकॉज एंटीसिमेट्री के लिए हम इसी तरह से वेव फंक्शन को डिफाइन करते हैं. ठीक है, psi1 psi2 की आप वैल्यू पुट कर सकते हो. psi1 क्या होगा? √2/L sin पाई x बाई एल. एक को ग्राउंड स्टेट में रखेंगे. psi2 के लिए हम क्या यूज कर सकते हैं? यहां x1 लिख सकता हूं मैं. ठीक है, sin 2 पाई x2 बाई एल. ठीक है, एक फर्स्ट स्टेट में होगा, एक सेकंड स्टेट में होगा, क्योंकि दोनों इलेक्ट्रॉन एक स्टेट में नहीं रह सकते. क्या आप कहें कि ये n = 1 में रहेगा तो एक n = 2 में रहेगा. ओके, so this is how you can find out the wave function. So आप देखिए पूरा का पूरा सिर्फ कॉन्सेप्ट है इस क्वेश्चन में. फाइन. ओके, लेट्स सी द नेक्स्ट क्वेश्चन. Yeah, this one is also interesting question. First let's see what is the question. Consider a spin half particle characterized by the Hamiltonian. This is the Hamiltonian of particle under this perturbation. Hamiltonian is given to us, perturbation is given to us. Second order correction in the ground state energy. आपको क्या करना है? सेकंड ऑर्डर करेक्शन निकालना है. तो सेकंड ऑर्डर करेक्शन कैसे निकालेंगे? Just give me. Okay, so how you will find out the second order correction in the ground state? So this is basically the perturbation based question. So first let's see what are the ground state for this Hamiltonian. So Hamiltonian is given to us that H is nothing but omega Sz. So can I write it like this? Omega, what is Sz? Simply we know h cut by 2 1 0 0 minus 1. ठीक है, when you solve this one, so you already know what are the eigenstate of this particular thing for this matrix, +1 and -1. यहां बाहर कांस्टेंट टर्म भी है, तो मैं क्या कह सकता हूं? there are two eigen values, omega h cut by 2, sorry, minus omega h cut by 2, and correspond to this the wave function is nothing but 0 1, ground state wave function, and then omega h cut by 2 correspond to this wave function is phi 2, that is 1 0. This thing we already know about the SZ matrix. Now what is the perturbation? Perturbation is given to us h dash gsx. So g is as it is, Sx is nothing but h cut by 2. And what is this matrix? 0 1 1 0. ठीक है, these things we know. Now how to find out the perturbation? So this is very important, that if perturbation is given to us and the eigenstates are already we have, then we can use this formula. Perturbation, first order correction in energy. फर्स्ट ऑर्डर करेक्शन क्या करते हैं हम? phi n h dash phi n. This is the formula for the first order correction. And for second order correction on any nth state, here I am writing any nth state. This is second order correction. So very simple, summation m is not equals to n. इस फॉर्मूले को ध्यान से रखना, याद रखना. Summation m is not equals to n, phi m h dash phi n mod square divided by en0 minus em0. This en and em are the energies of actual wave function, actual Hamiltonian, original Hamiltonian without the perturbation. ठीक है. सो फॉर दिस पर्टिकुलर केस में क्या कर सकता हूं, हमें किस में निकालना है? ग्राउंड स्टेट में. दिस वन इज द ग्राउंड स्टेट, n इज इक्वल टू 1. सो आई कैन राइट इट लाइक दिस, E12 summation m is not equals to 1. Ready? M is not equals to 1, and this is mod phi m as it is. What is h dash? H dash is nothing but simply gsx, and this is phi 1 mod square divided by, इस समीशन पूरे पे है, ध्यान रखना, दिस पे एंड दिस पे, E10 minus em0. Now next, now this is very interesting. We have to open up this summation. तो m की क्या क्या पॉसिबल वैल्यूज हैं यहाँ पे? m can't be 1. तो m क्या हो सकता है? There are only two possibilities. यहाँ देखिए हमारे पास सिर्फ दो ही फंक्शन है, phi 1 phi 2. तो या तो m की वैल्यू ये होगी या m की वैल्यू ये होगी. ठीक है, 1 हो नहीं सकती बिकॉज दिस इज द रिस्ट्रिक्शन. सो m इज ओनली 2. ठीक है, तो m की जगह हम 2 पुट कर देंगे. सो दिस बिकम सिंपली phi 2 gsx phi 1 mod square divided by E10 minus E20. Now you can put all these things. फर्स्ट मैं इसे एनर्जी को अलग से लिख देता हूँ. 1 ओवर E10 इज नथिंग बट माइनस ओमेगा एच कट बाई 2 माइनस ओमेगा एच कट बाई 2 into what is this phi 2? Phi 2 is 1 0, so I can write it like this, 1 0, and then g h cut by 2 0 1 1 0, and then 1 0 mod square. So this is nothing but g square h cut square by 2 into omega h cut, sorry this is 4, not 2, this is 4. ठीक है, with minus sign. And when you solve this whole thing, this is just the matrix, so when you do this thing, this will become 1. So this is simply minus g square h cut over 4 omega. Simple solution. Now you can see what is the best matching answer. This one is the answer. Of course h naught is not there, but it's okay, no problem. ठीक है. So it's a very simple and straightforward question. The thing is you have to remember this formula and how to implement this formula. ठीक है, यहाँ आपको कंफ्यूज नहीं होना है. कई बार आप गड़बड़ कर दोगे कि इसको आप मान लोगे ग्राउंड स्टेट 1 0 को. दिस इज नॉट द ग्राउंड स्टेट बिकॉज दिस इज h cut by 2. This is minus h cut by 2. So ground state is this one. Fine. Okay, see the next question. Yeah, this one is very simple and straightforward question, that is spin half particle in this particular state. आपको क्या given है कि spin half particle है and the state is given this 1 by root 2 up state down state. This is given to us. Are the eigenstate of Sz operator the expectation value of spin angular momentum measured along x direction? What we have to find out? Expectation value along the x direction. That means we have to find out the expectation value of Sx. कैसे करें? वेव फंक्शन ऑलरेडी गिवन है, Sx भी हमारे पास. आई कैन डायरेक्टली से psi Sx psi. दिस इज द एक्सपेक्टेशन वैल्यू. कैसे करें? देखो इसको मैं इस तरह से लिख सकता हूं. दिस इज 1 बाई रूट 2. दिस इज स्पिन अप स्टेट. सो कैन आई से दिस इज 1 0 प्लस दिस इज स्पिन डाउन स्टेट. दिस इज 0 1. So finally I can write it like this, 1 by root 2 1 1. Now I can put in this equation. So this will becomes 1 by root 2 as it is, and this will become 1 1. And what is Sx matrix? अभी लिखा हमने h cut by 2 0 1 1 0, and then psi as it is 1 by root 2 1 1. क्या होगा ये देखिए, दिस इज h कट बाई 2 and 2 plus 2, this is 4, 2 into 2, this is 4. and when you do this thing, करिए देखिए क्या होगा, this 1 1 as it is, this is 0, this is 1, and this is also 1. So this is h cut by 4, and you do this thing, this is simply 2, so this is h cut by 2. So the best answer is this one, h cut by 2. तो देखिए क्वेश्चन बड़े सिंपल हैं. इन दीज काइंड ऑफ क्वेश्चंस द थिंग इज यू मस्ट रिमेंबर दीज मैट्रिक्सेस कि Sx मैट्रिक्स क्या होगी, Sy मैट्रिक्स क्या होगी, Sz मैट्रिक्स क्या होगी. ठीक है, मैट्रिक्स क्या होती है, इनके आइगन स्टेट्स क्या होती हैं, ये भी आपको याद रखना है कि इनके आइगन स्टेट्स और आइगन वैल्यूज क्या होती हैं, सो दैट यू कैन डायरेक्टली हैंडल दिस काइंड ऑफ क्वेश्चंस. ठीक है, क्योंकि आपने हमें क्लासेस के टाइम पे किया है हमने कि दैट दिस इज द आइगन स्टेट ऑफ Sz, आइगन स्टेट ऑफ Sx क्या होगी, आइगन स्टेट ऑफ Sy क्या होगा. ठीक है, सो यू मस्ट रिमेंबर ऑल दीज मैट्रिक्सेस. फाइन. ओके देन, दिस इज all about for today's session. So rest we will do in the next classes. Okay then, thank you so much.